Alright, in this video we are going to be talking about scientific notation. I want to start off by reviewing a little bit about our place value system and what it means to multiply and divide by powers of 10. And we're looking for a pattern here. What is 3 times 10? Well, that's 30, right? And hopefully you notice that our place value system is just like multiples or powers of 10, right? We go from 10 to 100 to 1,000, multiplying by 10 each time. And for that reason, if we take any number and multiply it by 10, we're just shifting that number to the next place value, right? This is in the tens place. We multiply it by 10, we move it to the hundreds place. This is in the hundreds place, so if we multiply it by 10, we're just shifting everything to the next place value. So that moves to the thousands place, right? And you can also kind of think of just like adding a zero, right? That's what, in effect, shifting the place value is. By adding a zero here, we're moving everything else to the left one. By 100, well, that's 2 place values, right? So we're going to shift this 3 from the ones place to the hundreds place, right? We shifted it over 2 places. This 30 is going to get shifted over 2 places, so it becomes 3,000. And this would become 30,000. And consequently, if we divide by 10, we're shifting to the right a place value. 300 divided by 10, well, we're just saying divide everything by 10, or move everything to the place value to its right. So this becomes 30, and this becomes 3. And if we remember about fractions, this becomes 3 over 10, right? 3/10, or 0.3, same thing. 300 divided by 100, same concept here, right? We're moving to the right 2 place values. So not the tens, but the ones. This just equals 3. This is our 0.3, and if we shift 3 to the right 2, then we're at 0.03, the hundreds place. And we have to put that 0 here to show that this is actually the second place value to the right of the decimal, or the hundredths place. That's going to help us as we have this conversation about scientific notation. A part of scientific notation is that we have to be comfortable with multiplying by decimals. And now that we've learned that a decimal is just a fraction, this is really easy. This is just 3 over 10 times 4. Right? Well, that's really, right, if we remember how to multiply fractions, that's just 12 over 10, which is 12 divided by 10, so we can just shift everything to the right 1 place value. So 12 becomes 1.2, right? If we shift the 1 from the tens to the ones place, and the 2 that's in the ones place over to the tenths place. So this right here becomes 1.2. And we can get kind of quick at this and say, well, what is 14 times 7? Well, that's going to come out to be 98, right? So this is 98 over 10. Or we can just shift that place value over 1 and figure out that it is 9.8. And where we're headed, I can kind of take a break and, how did I do that quickly in my head? I can use the distributive property, right? 14 is really 10 plus 4. And that whole thing is being multiplied by 0.7. So I said, okay, this is 70 over 10, right? Because 7 times 10, we could write this as 7 times 10 over 10. That's 70 over 10, or 7. And this is 7 times 4 over 10, so that's 28 over 10, or 2.8. Just a quick way to do some mental math, since 14 times 7 may not just be instantly memorized for us. And that's kind of what I'm getting at here. If I ask you what's 25 times 6, well, really that's 6 times 5 and 6 times 20, right? We can write 25 in expanded form as 20 plus 5, and if we're multiplying that by 6, then that's 6 20s and 6 5s. And this is going to become really useful for scientific notation. Because if I said, what's 2.5 times 6? I can pretty easily say, hey, this is the same thing as 6 times 2 and 6 times 0.5. Okay, well, what is 6 times 2? Well, that's 12. That's pretty easy, right? Plus, well, what is 6 times 5 over 10? That's 30 over 10, or 3. So 2.5 times 6 is 15. I would implore you to pause the screen and kind of do the same thing here. Figure out, this is 3 plus 1 over 10, and multiply both of those by 4 and see what you get. All right, so back, this is just our place value, right? And we remember we're multiplying by 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. Well, we can kind of take advantage of this, right? Exponents shorten the process of multiplying. So instead of writing this out as, 10 times 10 times 10 times 10, I can just say that this is 10 to the fourth, right? When I say 3 times 10 to the fourth, I really mean that there is a 3 in the 10 to the fourth place, right? This is a 10 to the 1 place. I'm sorry, that's a 10 to the 0 place. 10 by itself is 10 to the first place. 100 is 10 times 10, which is 10 squared. 1,000 is 10 times 10 times 10, or 10 to the third. Right? We just said this one, 10 times 10 times 10 times 10. So if I say 3 times 10 to the fourth, I just mean there are 3 10,000s, which would, of course, would be 30,000. So I would, just to kind of review, okay, well, what this is let's see, that's the 10 to the 0, the 1, the 2, the 3, the 4, the 5, the 6. This is 10 to the 6th place, right? And what number is in the 10 to the 6th place? Well, it's a 4. That's 10 to the 0, 10 to the 1, 10 to the 2, right? 100, 10 squared, 10 times 10. So that's 3 hundreds, or 3 10 squares, because 10 squared is 100. This is 2 10,000s, or 2 times 10 to the fourth. Well, now we need to talk about what happens when we have a decimal coefficient here, right? We're going to tie all of this together. 3.4, that's really 3 times 100. I'm just going to say 3 times 10 squared, because we know 100 is 10 squared. And 4 over 10 times 10 squared. Yeah? And we can multiply this out. What's 4 times 10 squared? That's 400. Over 10. Well, when we're dividing by 10, right? When we're dividing by 10, we just move everything over to the right one, or get rid of one of those zeros. So we really have 300 plus 40. 4 over 10 times 100, that equals 40. So 340. We can do the same thing here. This is 330, right? 0.3 times 100, that's just 300 divided by 10, because this is the 10th place, so we get 330. And we can kind of work this backwards. We could say, hey, 340 in scientific notation, that's 300s and 0.4 hundredths, or 3.4 hundredths. The last thing we need to understand before we fully get this process is the idea of the most significant digit. In this number, we have a 4, a 7, and a 9. Which one of those digits represents the largest quantity? Well, this equals 9. That's not the largest quantity, right? This equals 70. Well, 70 is a lot more than 9, but it's still not the biggest digit here. The biggest digit is the 4. Even though it's not the largest character, because of the place that it's in, this means 400 of something. So this is the most significant digit. And we might kind of get the intuition that the number furthest to the left is always going to be the most significant, right? Each place value increases as it goes to the left. So that's 8, that's 30, that's 100, that's 8,000, 90,000. This is 500,000. This is the most significant digit. When we're writing numbers in scientific notation, we're trying to make them easier to read. So we can leave this as 123,000. And this isn't a huge number. I chose not to use a huge number for the example, just to kind of get through it easier. But, if we're saying, wow, it's a lot of characters, we need to make this simpler to read. Well, what's really important is that we're talking about hundreds of thousands, right? We could write this as 12,300 times 10, right? Because if we times 10, we just add a 0, right? And we're back to where we started. We could write this as 12.3 times 10,000, and we would have to add 4, zeros onto here. But that still, or 1, 2, 3, 4, that still does not make life very easy to read. That's still kind of confusing that actually equals 100,000. But if I write down 100,000, this is incredibly easy to read. There's 100,000, and then there's some smaller numbers. Well, what are those? Well, that's one place value to the right, so that's 20,000, and that's two place values to the right, so that's 3,000. So this can kind of quickly become converted into 100,000, and really it's 100,000 and 20,000 and 3,000, or 123,000. So our process here to convert a number by scientific notations, figure out what the largest place value is, right? So, or the most significant digit. So we say, okay, this is the hundreds. So what times 100 is 500? Well, 5 times 100. And, right, and we've got 40 here. Well, what times 100 equals 40? Well, 0.4, right? That'd be 400 divided by 10, or 40. So we get 5 times 10 squared and 0.4 times 10 squared. And we can simplify this to say, well, that's just 5.4 times 10 squared. So for here, as a group, we would discuss it, but the largest place value is going to be what? This is the 0, 1, 2, 3, 4, 5, 6, 7, 8. This is the 10 to the 8th place value, right? And we have a 4 there. And then to the right of that, we've got a 2, right? We're going to put it in the 10th place to show it's one place value to the right, dividing by 10. And then 2 place values to the right, dividing by 100. This is the 100th place. We have a 7. So we have 4.27 times 10 to the 8th. And I would encourage you to pause and work through some of these problems to see how this works out. And we can kind of check our work, right? We can say, hey, let's check this. 4 times 100. Yeah, that's 400. 2 over 10 times 100. That'd be 200 divided by 10, or 20. Yeah, that's what we need. And then this 7 over 100, right? This is in the hundreds place. That's going to come out to be 7. That's what we need it to be. So yes, this does in fact equal this. There's going to be more videos in scientific notation. I really encourage you to go to the Khan Academy. This is just an introduction. You know, scientific notation is a huge concept. It's okay if this is still a little sticky. We're going to keep working on it. Thank you so much.